my friends, today we are going to discuss about the new subchapter that is called the angular measurements and the measurement of surface finish. So, in this particular case from the name itself you can understand that we are going to measure the angle of different parts or maybe the objects. Now, let us start with the what is angular measurement. So, generally it is a one kind of precise measurement of angles is one of the important requirements in workshops and the tool rooms. Sometimes we are going to prepare any kind of helical shapes or maybe the conical shapes. So, we need the precise angles, say suppose 30 degree, 60 degree. So, these all are the normal, but if I need the 33 degree or maybe the 67 degree. So, that time we need the precise angle measurement over there. Then it is a measure of the opening between two lines which meet at a particular point. So, suppose this and this. So, I am going to measure the angle in between that. There are a wide variety of geometric features that are measured in angular units. What are those? Some typical measurements like tapers of bores, flank angle and included angle of a gear. So, suppose I am going to prepare some kind of gear. So, I want to measure the angle made by a seating surface of a jig with respect to a reference surface. Say suppose I am having, then whether it is perpendicular or maybe it is having some angle. So, that we can measure taper angle of a jib and so on. The angle reading is also used as a measure of the error of alignment of the machine parts. Now, what are the instruments? So, generally as I told already we are using these particular techniques for the diverse applications. So, generally different types of methods and equipment are available to measure the angles in common angular units like degree, minute and second. Angle measuring devices are classified on 4 different sub things which is called the line standard angular measuring devices. Generally we are using the vernier level protector. Then face standard angular measuring devices, we are having some sine bar based on the sine principle and the sine center. We are having some measurement of inclines like spirit level or maybe the clinometer. Angle comparators, we are having some kind of auto collimator things. Now, we will discuss all these things one by one. So, first is the line standard angular measuring device. So, line standard gives direct angular measurement from the engraved scales in the instruments itself. They are not very precise, hence they are not used when high precision is required, because as I told already so many times that when I am using some kind of instruments to measure something, that instrument should be very precise. Then only the after using that particular instruments we can get the exact dimensions of that particular objects or maybe the machines. But if that instrument is having some errors, so automatically that error will come into the system. So, we are not going to get the accurate results. Vernier bevel protector is the most commonly used line standard angular measuring. Now, what is vernier bevel protractor? It is the simplest instrument for measuring angles between two faces. It consists of two arms and engraved circular scale. Two arms can be set along the faces between which the angle is to be measured. So, it simple looks like this. So, now it is having the one arm is this one, another arm is this one. So, just if we make certain kind of angles, then how much angles we can get it from this particular dial. So, dial is having some main scale and also some vernier scale. So, automatically we can get some kind of precise one, but my question is that if these dial dimensions or maybe there is some error in between the scales or maybe the lines, then that system will automatically come into our system. So, that is why sometimes it is not so precise or maybe some high precision cases we are not going to use this kind of techniques. Next one is called the face standard angular measuring devices. So, first one is called the sine bars. So, generally as I told already, this is based on the principle is the sine principles on which it is working. So, generally the sine principles uses the ratio of the length of two sides of a right triangle in deriving a given scale. So, simple what is happening, I want to measure this particular angle. So, I need this value, I need this value, or maybe I am getting this value or maybe this value, and simple I am getting this angle. So, the sine bar in itself is not a complete measuring instrument. Another datum such as a surface plate is needed, as well as other auxiliary equipment, notably slip gauges and indicating device to make the measurements. So, here we need some kind of supplementary instruments also. Sine bars used in conjunction with slip gauges constitute a very good device for the precise measurement of angles. Some holes are drilled in the body of the bar to reduce the weight and facilitate handling. So, the real image of the sine bar I will show you in the next slides. So, whatever the scale generally you are using, we are putting certain kind of hole, simple, just we are removing some kind of material, so that it will be lesser weight. Sine bars are made from high carbon, high chromium, corrosion resistant steel, hardened, ground and stabilized. Now, this is the real image of the sine bar. So, how we are measuring that angle of small size components? For measuring the angle of small size components, a sine bar is set up at an angle on a surface plate by suitable combination of slip gauges. So, simple, now my material is having these angles. Now, what is that? I am using certain kind of gauge blocks, so that it can rest properly onto that particular surface. Then simple thing, sin theta, that is the perpendicular by the hypotenuse. So, simple small h by capital L. So, theta is equal to sin inverse small h by capital L. So, here L is the distance between the center of the ground cylinders. So, that is the L. H is the height of the ground blocks. So, simple this one, and theta is the taper angle of the workpiece. So, that means we are going to measure these particular things, that is the theta. Same thing, now if we are having some large scale components, so in that case what we are doing? So, when component is too large to be mounted on the sine bar, the sine bar can be mounted on the component itself. So, the height over the rollers is measured by means of a vernier height gauge. So, simple, we are measuring the height here over there. A dial gauge is also used to check the measuring pressure. Height gauge is adjusted until the dial gauge reads 0 reading. Now, the angle of the component is given by sin theta is equal to R1. So, the reading of this one vernier scale minus R2 of this vernier scale by capital L. So, L is nothing but this distance. So, theta is equal to sin inverse capital R1 minus R2 by capital L. Now, come to the sine center. So, it is a special type of sine bar is sine center, which is used for conical objects having a male and female parts. It cannot measure the angle more than 45 degrees. So, if you are having some products which angle is less than 45 degree, then only we can precisely measure. If it is more than 45 degree, then we cannot. It has block holding centers which can be adjusted and rigidly clamped in any position depending on the length of the conical workpiece. So, these two are the adjustable ones. So, it can come closer or maybe it can go at a certain distance. Extremely useful, since the alignment accuracy of the centers ensures that the correct line of measurement is made along the workpiece. So, this is having the two centers over there. So, now simple, we are having the support plate and the rollers, on that we are putting that particular equipment and then we are measuring. Then how we are measuring? Here measurement of semi conical angle using the sine center. The component being checked is placed over the surface of a sine bar. So, this is the case. Now, this is our exact component over there. Dial gauge is moved over the component throughout its length. So, dial gauge we are moving. Then if there is a variation in parallelism of the upper surface of the component and the surface plate, it is indicated by the deflection of the pointer also. So, now you see that these angles, actually if it is exactly that point is this point tip is touching all the points, that means it is absolutely flat over there. Now, the slip gauge's height is adjusted so that the dial indicator reads the 0 position. In this particular case, it will show you the 0 value. Now, for the dial gauge to read 0, the accurate semicone angle is as given by alpha. Alpha means nothing but this one, alpha is equal to theta, that means here is equal to sine inverse capital H by capital L. So, this by this. Simple thing is that we are having that sine bar, we are putting like exact like a mirror image with the sine bar, and then we are measuring the angle. Now, when we are measuring the inclines, so we are using the first thing is called the spirit level. So, basically if you can see that whatever the equipments or maybe the some kind of precise equipments we are using in our laboratory like optical microscope, some kind of equipment. So, this spirit level is permanently attached with that particular machines, where we need to put that machines into the exact horizontal positions, it should not be tilted. So, now generally the spirit level, bubble level or simply a level is an instrument designed to indicate whether a surface is horizontal or maybe the vertical one. Constructions of the spirit level. So, as I told already, it consists of a closed glass tube of accurate form, it is called as the vial. It is filled almost entirely with a liquid, leaving a small space for the formation of an air or maybe the gas bubble. Generally low viscosity fluids such as ether, alcohol or maybe the benzol are preferred for filling the vial. Proper liquid and material for the spirit level is required as temperature variations in the ambient condition cause both liquid and vial to expand or maybe the contractions. To reduce the effect of heat transfer in handling, spirit levels are made of a relatively stable castings and are equipped with thermally insulated handles. So, simple, we are putting this one onto the surface, and then within this range if your bubble, air or gas bubble will lie, so that means it is perfectly horizontal. If it is having some angle, so gas bubble will come into these sides or maybe the that side. So, by movement of the gas bubble we can simply make it into the exact horizontal positions. So, generally we can adjust. Now, working of a spirit level, the liquid due to its greater specific weight tends to fill the lower portions of the closed space, upper side of the vial is graduated in the linear units. When the base is horizontal, the bubble rests at the center of the graduated scale. Inclination of a surface can be known from the deviation of the bubble from its position when the spirit level is kept in a horizontal plane, that I have already explained. So, generally we are getting the image like this. Applications, a precision level is used to check and correct the twist in a machine or maybe the workpiece. Now, next one is called the clinometer. So, it is a special case of spirit level. While the spirit level is restricted to relatively small angles, clinometers can be used for much larger angles. So, when you are using the spirit level, it is having some limitations, it cannot go to measure the bigger angle or maybe the large angle. So, clinometer will solve that particular problem. It comprises a level mounted in a frame, so that the frame may be turned to any desired angle to a horizontal reference. How it looks like? It looks like this. So, we are having that eyepiece, we are having that spirit level over there. It is a fine adjustment, this is the angle it will show, it will the lock, because after fixing it you can lock that particular things and it is having a very strong base over there. So, to measure the clinometers, the base is kept on the surface of the workpiece. Say suppose if you are having the workpiece, it looks like this. Lock nut is loosened and the dial comprising the circular scale is gently rotated till the bubble in the spirit level is approximately at the center. Now, lock nut is tightened and the fine adjustment nut is operated till the bubble is exactly at the center of the vial scale. Rotation of the disc can be read on the scale, it represents the deviation of the surface over which the clinometer is placed from the horizontal plane. So, now you see, first initially if it is some making some angle over there, so automatically the bubble will be somehow here or maybe the here. So, depending upon that I am going to change the position of this spirit level and then I am making it lock. then automatically from this scale I can understand that how much is the angle it is over here. Applications used to determine the straightness and flatness of the surfaces, also used for setting inclinable table on jig boring machines and angular jobs on surface grinding machines. They provide superior accuracy compared to ordinary spirit levels. Now come to the angle comparators. Angle comparators are the metrological instruments used for finding the difference between two nearly equal angles. In practice, they are frequently used in calculating the difference between the angle of working standard gauges or maybe the instruments. It is also used in measuring angle of a number of angle gauges rung together or the angle between two faces of a standard polygon. So, like this. The most widely used angle comparators are the autocollimators. Or what is autocollimators? The two main principles used in an autocollimator are projection and the refraction of a parallel beam of light by a lens and change in direction of a reflected angle on a plane reflecting surface with change in angle of incidence. How it is working? The autocollimator measures the deviation between the emitted beam and the reflected beam to detect the angular movement. In this diagram of an autocollimator, the angle of mirror deviations alpha, where is the alpha? So, this is the alpha over there. So, is calculated by using the formula alpha is equal to del y by 2f. So, what is del y? It is nothing but the deviations. So, f is the focal length of the autocollimator, del y is the vertical deviations of the reflected beam due to angular movement of the workpiece. What are the applications? Checking of an internal right angle, comparative measurement using master angles, measuring straightness and flatness of the surface for machine tool adjustment settings. Now, when we are making some kind of materials and all these things, sometimes it may possible that by naked eyes we are thinking that the surface is smooth, but if you see it through some kind of optical microscope or maybe some kind of microscope, so or maybe camera, you can find that surface is exactly not the smooth one, maybe it is having some roughness or maybe the waviness on top of that. So, how to measure that particular roughness? So, surface roughness means surface roughness often shortened to roughness, it is a component of surface texture as I told already, and engineering components processed by casting, forging, drawing, welding or stamping etc., may not have equally finished surfaces. So, now I am making a line over there. So, if you see now you can find almost it is straight, but if you see it through the microscope you can see that there is a some kind of variations into that particular line. So, that how much variations over there, that is the question. So, if these deviations are large, the surface is rough, if they are small the surface is smooth. So, like roughness and waviness, these all are coming under the surface roughness. Now, elements of surface roughness, like surface of the part is confined by the boundary which separates that part from another part, substance or maybe the space. What is profile? Profile is defined as the contour of any section through a particular surface. Actual surface, this refers to the surface of a part which is actually obtained after a manufacturing process. Nominal surface, a nominal surface is theoretical geometrically perfect surface which does not exist in practice, but in an average of the irregularities that are superimposed on it. Center line, center line of profile is the line parallel to the general direction of the profile for which the areas embraced by the profile above and below the lines are equal. So, it is almost the center. So, top and bottom almost both are the in the equal height. Mean line of the profile is the line having the form of the geometrical profile and dividing the effective profile, so that within the sampling length the sum of the squares of distances between effective points and the mean line is minimum. When the waveform is repetitive, the mean line and the center line are equivalent. So, this is known as the peak line, this is the mean line and this is the valley line, because this is valley and this is the maximum peak over there. This is the total sampling length. That means, from where to where you have starting point and your ending point. So, that is your sampling length. Lay direction, predominant directions or pattern of the surface texture. What is roughness? Roughness refers to relatively finely spaced irregularities such as might be produced by the action of a cutting tool. Roughness height, this is rated as the arithmetical average deviation expressed in micro inches or maybe the micrometers normal to an imaginary center line running through the roughness profile. Roughness width, roughness width is the distance parallel to the normal surface between successive peaks or ridges that constitute the predominant pattern of the roughness. So, from this particular image you can understand the whole things. Then what is the roughness height, what is the roughness width over there. So, two consecutive peaks and this is the total width or maybe the waviness. Here is the roughness width cutoff, here it is the lay directions, there it is some kind of flaw has been detected and waviness height is this one. So, roughness width cutoff sampling length, this is the maximum width of surface irregularities that is included in the measurement of roughness height. So, when we are talking about the waviness, actually it is almost like similar, but when you are talking about the roughness, so it is not the regular one, it is the irregular one. This is always greater than roughness width and is rated in inches or maybe the centimeters. Now, come to the waviness. Waviness consists of those surface irregularities which are of greater spacing than roughness and it occurs in form of waves, as I told already. So, some kind of similar kind of things and it's there is no irregularities over there, but when you are talking about the roughness there is some irregularities. It may be caused by vibrations, machine or work deflections or warping, etc. Waviness width, it is the distance between successive wave peaks or successive wave valleys. Waviness height, it is the distance from the wave peak to valley. Flaws are surface irregularities or imperfections which occur at infrequent intervals and at random intervals. Such imperfections are scratches, holes, cracks, pits, checks, porosity, etc. Now, how to measure the surface roughness? There can be many ways through which the surface roughness plot can be evaluated. Few of the most popular methods of surface roughness plot interpretation are generally we are finding in the books or maybe some journal papers or maybe normal days we are using, that is number one is called the root mean square value or maybe the RMS value in short. Second one is that center line average CLA or maybe the arithmetic mean deviation denoted as RA. Third one is the maximum peak to valley height denoted as RT or maybe the R max. Number 4, average of the 5 highest peaks and 5 deepest valleys in the sample denoted as RZ. So, this is the average value. Now, first we are going to discuss about the root mean square value, in short RMS. The center line is first located such that the sum of the areas above the line is equal to the areas below the line. So, now if we calculate the area of these portions and the area of these portions, so it is almost same. The distance above the center line are taken as positive and below is as negative. So, if we take positive and this one will be the negative one. Then n measurements are made plus or minus from the center line vertically to points on the profile and are called the y1, y2, y3, y4, y5 like this way. RMS calculations. So, RMS value is equal to root over y1 square plus y2 square plus y3 square plus dot 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 up to yn square by n. So, n is nothing but the measurements, that how many times you have done, where yi is the profile deviations. So, whole as a whole it is coming that summation over yi square by n root over whole. Second one is come to the center line average or maybe the CLA or maybe the arithmetic mean deviations or maybe the RA. In this method the surface roughness is measured at the average deviation from the nominal surface or center line. Arithmetic average or center line average is defined as the average value of the ordinates from the center line. The algebraic sign of the coordinates are not considered. How we are going to calculate it? So, arithmetic average, so A is equal to R A is equal to 1 by L. What is L? So, from here to here, then integration 0 to L y x dx, or approximately R A is equal to summation over I is equal to 1 to n y I by n. Maximum peak to valley height, that is the R max or maybe the R T. This is the parameter which is simplest to be determined from the graph of the profile. However, this does not give complete characteristics of surface roughness. This parameter is however important when the roughness is to be removed, for example by polishing to increase the fatigue resistance of the work itself. So, in this particular case this is the peak line, this is the mean line and this is the valley line. So, when we are talking about the peak line, that is denoted by the RP from the mean line, the whole highest peak and the lowest peak distance is known as the R max, and from the mean line to the valley line the highest point is known as the RV. So, RP as I told highest peak, RV deepest valley, and R max, that is nothing but the RP plus RV. Next, average peak to valley height, nothing but RZ. This parameter is easier to obtain from a profile graph than RA. This is the average difference between the 5 highest peaks and the 5 deepest valleys within sampling length measured from a line drawn parallel to the general direction of the profile. This line does not cross the profile, see R1, R2. So, all the peaks from the datum line just we are making or measuring the height. So, the parameter is obtained as Rz is equal to 1 by 5 R1 plus R3 plus R5. So, if you see properly R1, R3, R5 these all are the positive one, and R2, R4, R6, R8 are the negative one if I put the center line in this particular area. Next, surface roughness measurement. The surface roughness may be measured using any of the following. What are those? Straight edge, surface gauge, optical flat and the profilometer. When you are talking about the straight edge, it is a tool with a straight edge used for drawing straight lines or checking their straightness. They are proposed in the automotive service and machining industry to check the flatness of machine mating surfaces. A pair of straight edge called winding sticks are used in woodworking to amplify twist in piece of wood. So, simple, we are putting the straight edge over there and then we are putting the spirit level. So, just to see that whether it is exactly horizontal or not, and then after that we are seeing that is there any gaps are present over there or not. If there is no gap, so it is completely sticking with another one. So, that means the roughness value of this one and this one is the same. So, this is the initial test actually. Second is the surface gauge. Surface gauges are used to measure the profile height of the surface. The attached scriber helps to mark out the surface profile with respect to a reference line. So, we are having the spindle, scriber or maybe the marker. So, suppose I am having one materials, I am having this pin and then pin will move like this, and by this way we can easily check that whether the pin is touching all the points onto the surface or maybe some points are missing. So, in this case this is the side view and this is the front view. So, on top of any materials or maybe sideways also you can measure. Next one is the optical flat. It is an optical grade piece of glass lapped and polished to be extremely flat on one or both sides, usually within a few tens of nanometers. They are used with a nanochromatic light to determine the flatness, surface accuracy of other surfaces. Working of optical flats: when an optical flat is placed on another surface and illuminated, the light waves reflect off both the bottom surface of the flat and the surface it is resting on. This causes a phenomenon similar to thin film interference. The reflected waves interfere, creating a pattern of interference fringes visible as light and dark bands. The spacing between the fringes is smaller where the gap is changing more rapidly, indicating a departure from flatness in one of the two surfaces. So, simple, we are having two polished surface and then we are touching each other. So, this is the optical flat one, this is your samples and these are the very smooth surfaces, and then we are passing the light. Then how to get the interpretations results? Straight, parallel and evenly spaced interference fringes indicate that the work surface flatness is equal to or higher than that of the reference surface. So, this is the optical flat and this is the test piece over there. So, here the flatness error of one fringe, that is lambda by 2, and test piece are perfectly flat over there. So, how we are comparing the results? Now, two adjacent fringe indicate a difference in elevations of 1/2 wavelength of the light used. So, by counting the fringes, differences in elevation of the surface can be measured to better than 1 micrometer. So, this is the flat surface, this is the convex surfaces and this is the irregular surfaces. So, generally we are getting the image like this. And the last one is called the profilometer. This is the most precise one, and for maximum cases nowadays we are using this kind of techniques, because accuracy level of this profilometer is too high, and not only that, it is giving you some kind of 3D image and 2D image, so that we can get the actual surface roughness and the value and actual data from this particular testing. A profilometer is a measuring instrument used to measure a surface profile in order to quantify its roughness. There are two types of profilometer, as contact profilometers and the non-contact profilometers. Say suppose I am having the tip. So, if the tip will move from a particular distance, that is known as the non-contact one, and if it will touch your surface and it will rub like this way, so that is known as the contact profilometers. So, if we talk about the contact profilometers, a diamond stylus. So, in this particular case generally we are using the diamond tip. Stylus is moved vertically in contact with a sample and then moved laterally across the sample for a specified distance and specified contact force. So, simple, they will move in this manner. So, they are going to cover a particular area. The height position of the diamond stylus generates an analog signal which is converted into a digital signal, stored, analyzed and displayed. It can measure small vertical features ranging in height from 10 nanometers to 1 millimeter. So, you can see that from these particular techniques we can measure into the nanometer level also. So, we can get the maximum finish of the surface. And what is non-contact profilometers? An optical profilometer is a non-contact method for providing much of the same information as a stylus based profilometer. It generally uses light instead of a physical probe. Surface texture is measured by optically scanning a surface with a light or maybe the laser. Optical or light based instruments may also use triangulation or maybe the interferometry to measure or capture a surface profile. Although most surface profilometers provide only a 2-dimensional or line file, some instruments can provide 3-dimensionals or maybe the aerial topography measurements. So, simple, in this particular case we are using some kind of lasers or maybe some kind of light source to measure the surface roughness, and your stylus is not touching your sample. So, that is why it is known as the non-contact profilometers, and this is the working principle. So, simple, we are having that camera and then we are having that samples over there, we are having the objectives, mirror, scanner. So, LED light source. So, simple, we are putting it onto the sample itself and then it is going back reflecting, and then after that we are getting some kind of measured signals over there, that is the waviness of your surface. Now, we have come to the last slide of this particular lecture. Now, in summary we can say the quantifications and measurement of angles is very important, as I told already, because when we need to make some kind of conical shapes or maybe some kind of helical shapes or maybe some kind of contour shapes. So, that time measurement and angle is highly required. So, different types of instruments are used to perform the angular measurements, like the bevel protector, sine bar we have already discussed, we have discussed about the sine center, we have discussed about the spirit level, clinometer, etc. The shape and size of irregularities on a machine surface like surface roughness also have a major impact on the quality and performance of that particular surface and on the performance of the end product. Many parameters have been established regarding the measurement and assessment of the surface roughness, and as I told already, so nowadays we are using the optical profilometer or maybe the AFM, atomic force microscopy study, by which we can get the more and more accurate precise surface roughness value of your particular equipment or maybe your surface. Thank you.